Hello students, this is a question of IIT JAM 2024. So in this questions we're given that our group has order 39. So in this kind of questions you first split the order of group into prime factors and check whether P divides Q minus 1 or not. If P does not divide Q minus 1, then we can directly say that group is cyclic. But in our example 3 divides 12, which is 13 minus 1. So we have two options. Either group will be abelian or it can be non-abelian. So what will it be? So we have to check for non-abelian first. Let's check for non-abelian. So now we will categorize this into orders and elements. Okay, so order 1, and this is number of element, we have 1. Now order P, we have Q into P minus 1, and order Q, we have number of element Q minus 1. So from this table, if the group is non-abelian, this table works. Okay, now let us check for order P. P means we have 3 here. Let's put this P, let's put this Q. So number of elements of order P will be Q into P minus 1, which will be 13 into 3 minus 1, which will give us 26. So there are 26 elements of order 3. So now we will find out number of subgroups of order 3. So which will be number of elements of order 3 divided by phi of 3. So 26 divided by 2, which is 13. So it has 13 subgroups of order 3. But in our question, if you see that there is exactly one subgroup of order 3, so we are getting a contradiction if we take the group to be non-abelian. So it cannot be non-abelian, so it must be abelian. So now you remember one result. If a group is of order PQ distinct prime and it's abelian, then it's necessarily cyclic. Okay, if G of order PQ and abelian, then these two condition implies necessarily cyclic. Okay, I hope it's clear. So option A will be our correct option.